Hello everyone, today let's take a look at QP90, which should be a straightforward Bayes question. So I have a bag of 100 dice, 99 of them are normal dice, and one of them is unfair that has a 2 on all 6 faces, and you draw one die at random and roll it 3 times, observing a 2 on each roll. So what's the probability that the next roll of the same die is also 2? Okay, so we define some events to make notation easier. We draw a probability space, you know the drill. And what we're trying to find is essentially we want the probability of X that the fourth roll is a 2, given that the first 3 rolls are all 2. So we have 100 dice and we draw one of them randomly, so the probability that we take out the one unfair dice is just going to be 1 out of 100. And obviously that means the probability that we draw fair dice is 99 out of 100, and this partitions our probability space. So we know the probability of X given that this event over here happens. So what's the probability that this event here happens in the first place? So we know the law of total probability at this point. If we choose the unfair coin, well then the probability that we get 3 2s in a row is obviously going to be 100% because every single face on that die is a 2. Then the probability that we get 3 2s in a row, given that we have a fair coin, is obviously pretty small. So I'll just draw it as pretty small over here. So this blue shaded region is the event 2 2 2. So we can actually calculate this now. So the density of this blue region, it takes up 100% of 1 out of 100 of the total probability space. Now for the fair coin, we have a 1/6 cubed chance of getting 3 2s in a row, and then that's going to occupy this amount of 99% of our probability space. So the total probability of this event occurring is just going to be the sum of these. It's going to be 1 out of 100 plus 1/6 cubed, which is actually 1 on 216 times 99 on 100. So now let's color X red, and the probability of X, given that this event occurred, is just the intersection that X has with this blue event divided by the total probability mass of the blue event, which is just this down here. So again, here it is just written down as a definition of conditional probability. So now in the event that we have a fair die and we tossed it 3 times in a row, getting a 2 every time, well, then the probability that our next flip is also a 2 is just going to be 1/6 because these flips are independent. So that tells us that X makes up 1/6 of the intersection between the event F and the event 2 2 2. Now instead, if we find ourselves in the event that we have an unfair coin and we flipped 3 2s in a row, well then the probability that the fourth flip is a 2 is going to be 100% again, because it's always a 2. So the event X occupies 100% probability mass within this region over here. So now we have everything we need to solve for this equation right here. We already have the denominator, obviously. And for the numerator, we're just going to take the intersection between the event X and the event 2 2 2, which is just all of the red region, right? So it occupies 100% of this 1 out of 100, and it occupies 1/6 of this up here. So we add on 1/6, I'll just say to the fourth, times 99 out of 100. Okay, so now let me just place this in the denominator over here. And then the rest of this is just basic algebra. I can cancel out a factor of 100 from all of these terms, and I get something like this. So now in the denominator, when I add 1 to that, I'm going to get 315 on 216. In the numerator, I get 1 plus 1 on 6 to the fourth, which is going to be 1 on 1296. Then multiply that by 99, so we'll have something like this. And then this is going to give me 1395 on 1296. And then I'm going to multiply by the inverse of this, which is going to be 216 on 315. These numbers are getting kind of big. When you end up getting this in lowest terms, it's just going to be 31 on 42, which will be our final answer, and that's roughly 73 or 74%. So yeah, on these you can see I'm mainly working with the Venn diagram just to give another perspective, because if you want to just see it with formulas, well then you can just check the explanation, right?